Welcome to a video on the identity matrix, and the goal of this video is to define an identity matrix. An n by n square matrix with a main diagonal of 1s and all other elements 0s is called an identity matrix, denoted with a capital letter I. And since the identity matrix is a square matrix, we usually denote it with the subscript as we see here for a 2 by 2, 3 by 3, 4 by 4 identity matrix, and so on. So again, the main diagonal will always be 1s and all their elements 0s. So if we have an identity matrix that has some special properties, and you can almost think of it as a 1 in algebra. Whenever you multiply something by 1, it doesn't change. So for example, if we have a matrix A that is an m by n matrix, then the identity matrix times A will equal A, and A times the identity matrix equals A as well, if that multiplication is possible. And if A is an n by n square matrix, then A times I will equal I times A, which will always equal A. Let's go ahead and perform some multiplication with the identity matrix to get a better feel for this. So for example, here we have a 2 by 2 identity matrix times another 2 by 2 matrix. Remember, this is a 2 by 2, this is a 2 by 2. Since these two numbers are equal, the multiplication is possible, and the result is another 2 by 2 matrix. So to find the element in row 1, column 1, we multiply row 1 by column 1. So 1 times 4 would be 4, plus 0 times negative 5, that's 4. To find the element in row 1, column 2, we multiply row 1 in the first matrix times column 2 in the second. We'd have 1 times 7 plus 0 times negative 2, which equals 7. And then here in row 2, column 1, we multiply row 2 times column 1. 0 times 4 is 0, and 1 times negative 5. And then for row 2, column 2, we have 0 times 7, which is 0, and 1 times negative 2, which is negative 2. And so the thing to notice here is, here's the identity matrix times a matrix A, and the result is matrix A again. And notice in the second product we just changed the order of multiplication. And let's go ahead and show the result will be the same. For this element here, we'd have 4 times 1, that's 4, plus 0. For row 1, column 2, we'd have 4 times 0, which is 0, and 7 times 1. And row 2, column 1, we'd have negative 5 times 1, that's negative 5, plus negative 2 times 0, negative 5. And then lastly, we have row 2 times column 2, negative 5 times 0, plus negative 2 times 1. And again, you can see the result is the same. This is matrix A times the identity. The result, again, is matrix A. So multiplication is commutative if we multiply a square matrix times the identity matrix. And let's go ahead and try one more here. Again, this is the identity matrix. If we call this matrix B, we would expect the result to be matrix B. Let's go ahead and check this one on the calculator. Let's go ahead and press second matrix. Let's go over to edit, press enter. Let's call matrix A the identity matrix. So it's a 3 by 3. And we have 1, 0, 0, 0, 1, 0, 0, 0, and 1. There's the identity matrix, and now let's go ahead and enter in matrix B. Second matrix, go over to edit, scroll to B, press enter. This is a 3 by 3. We'll go ahead and enter in these elements here. And there it is. Let's go back to the main screen. Second, quit. We'll multiply matrix B, second matrix, scroll to B, enter, times the identity matrix is in matrix A. So second matrix, enter, enter, and we can see the result is matrix B as we expected. So now you can probably tell why you can think of the identity matrix as the number 1 in algebra, because when you multiply it, the result is the same. Okay, in the next video we'll talk about inverse matrices. Thank you for watching.